Now we are going to study question from July 2011 exam question 1. Okay, everyone give the heading. July 2011 question 1. Now try to see the scenario, what the question want to say. A single cylinder double acting vertical bilge pump. Okay, everyone, which type of, here number of cylinders is how much? 1. Double acting, see the word here, double acting means what? From both the sides of piston water will be, okay, there will be water on both sides of the piston. A single cylinder double acting vertical bilge pump operates at 50 revolution per minute. What they are saying, operates at what? 50 revolution per minute. It means what, guys? N is how much? 50 revolution per minute. So whenever we have a N, from N, what is our next target? From N, what we are going to calculate? We are going to calculate omega, angular velocity. So therefore, omega is equal to what? What is the relation for omega? 2 pi n by 60. So omega will be equal to what? 2 pi into 50 divided by 60. Okay, everyone? So please, everyone, try to do the calculation. Everyone, please try to do the try to calculate the omega. 2 pi into 50 divided by what? 60. How much answer we are getting? Okay, 5.236 unit is what? Radian per second. Okay, guys, are you getting my point? Try to see the scenario here. So here we have a double acting bilge pump. Try to see the scenario here. Against a discharge pressure of what? How much discharge pressure is there? P is equal to what? 1.8 bar. But in mechanics, what is the unit of pressure? Favorite unit of pressure to us? What is the favorite unit of pressure? Newton per meter square. So how to convert 1.8 bar into Newton per meter square? So 1.8 into 10 raised to the power 5 Newton per meter square. Try to see the scenario here. Very simple discussion. Now the next point is what? And the piston has a dia. Okay, how much is the dia of piston? See the scenario here. Dia of piston is how much? Piston dia is what? 120 mm. But our favorite unit of dia is what? What is our favorite unit of dia? Our favorite unit of dia is what? 0.12 is meter. Okay. Now the piston may be assumed to move with simple harmonic motion. See, I told you in the previous lecture what we discussed, guys. Whenever there is a, how to identify this question belongs to simple harmonic motion, because in that question they will clearly mention that question is of simple harmonic motion. Means here motion of the piston is what? Simple harmonic motion. Everyone getting my point? Try to see the scenario here. The volume of the piston rod may be ignored. Now next point will be what? The pump is driven by a motor. The pump is driven by the motor with efficiency of motor is how much? How much efficiency of motor, everyone? 78%. Efficiency of motor is what? 78%. 78% means what? For calculation we will use 0.78. Try to see the scenario here. Very simple discussion. Okay. Now at a given instant, try to see the scenario. At a given instant, piston is 90 mm from the top of the stroke. See, I am going to draw here. Before going further, guys, I am going to draw that basic diagram, that piston movement diagram. Okay, stroke diagram, where we can mention all these things. So see the scenario here. Suppose this is what? A path of piston. This is what? Just imagine that this is a path of piston. In this path, piston is moving. So this topmost point, this is bottommost point. What will be the name for topmost point, everyone? What will be the name for TDC? So top dead center for the piston. This is what? A bottom dead center for the piston. Then there will be what? Try to see the scenario. So here, this distance from here to here, this distance will be what, everyone? What will be this distance? Stroke. Exactly in between. What is the exact in between point? What we call it as? Fixed point or mid point or mid stroke. So this point is what? Our mid stroke. Then try to see the scenario here. Then this distance will be what? From TDC to mid stroke, this distance will be what, everyone? R. Then this distance will be what? Try to observe the scenario here. So this distance will be what? From mid stroke to BDC, bottom dead center. This will also R. And what is the meaning of R? R stand for amplitude of SHM. What is the meaning of R, everyone? R means amplitude of SHM. Now next point will be what? Now what they mentioned in the question, I am going to read the question here, that part of the question. At a given instant, guys, see the second paragraph of the question. At a given instant, the piston is 90 mm from the top of the stroke. What is the meaning of top of the stroke? Means from TTC, piston is what? 90 mm. Okay, 90 mm away from the stroke. And mass of the piston and entrapped water is what? 6 kg. So how much mass they have given us here? Mass is what? 6 kg. And this distance from top, from the guy's top stand for TDC. Try to see the scenario here. So this is what our point of interest. So from this point, our distance will be what, everyone? How much this distance? Okay, this distance is what? 90 mm. Okay, everyone getting my point? Try to see the scenario here. So this distance is what? 90 mm. Now then here. So okay, good. This much things they have given us in the question. Now what they are asking us in the A part? Everyone try to see the scenario. Force required to move the piston. Okay, what they are asking us means that rod force. They are asking us force required to move the piston. And B part, they are asking us input power to the motor. How much power we are giving to the motor. Try to see the scenario. Very simple discussion. Not that much difficult discussion. Very simple discussion. But for this discussion, some things are missing here. Now guys, what they are asking us here. Now, what is missing here? Can you tell me? Which thing is not known here? Which is unknown things here? The most unknown thing, that is very means in earlier question, in previous questions, we have that thing is given to us. What is missing here? See, in A part they are asking us force. In A part, what is our target here? In A part they are asking us F. Okay. How to calculate F? Try to see the scenario. Here I am going to draw force diagram for this one. Suppose this is water piston. This is water piston. Everyone try to see the scenario. This is water. Our piston diagram. I am just drawing a schematic view. This is water piston. Okay. Now here weight of the piston and that entrapped water. What will be the dead weight of piston and entrapped water? How much mass they have given us? 6 kg. So weight will be how much? Weight will be how much? 6g. Then there will be what? Pressure. So here we have a what? This is water. A pressure force that will act uniformly. Then there will be what? F. Okay. That force required to move the piston, that is given by the rod. Now here, see how will be the direction of acceleration here, guys? How will be the direction of acceleration here? How will be the direction? Downward or upward? In this scenario, guys, for this scenario, what will be the direction of acceleration? Downward or inward? Why downward, guys? If downward, why downward? Why downward? Try to see the scenario here. See here what they are asking us in. See the second paragraph of the question. What they have given us a second paragraph of the question. At a given instant, piston is 90 mm from the top. Means from the top, piston is what? 90 mm. So it is means what? Above the mid stroke. Just we are assuming, guys. If we don't know exact, we assume it is. Means from the top, it means approximately it is above the mid stroke. If it is above the mid stroke, guys, what we discussed earlier in our theory, what we discussed, acceleration is always directed towards what? Acceleration is always directed towards what? Towards fixed point or towards mid stroke. So when the acceleration always directed towards mid stroke, so it means what? When our piston is at this location, guys, this is only schematic view, point diagram, okay, line diagram like that. So acceleration is at this position, means piston is at this position, and with respect to piston position, where is our fixed point or mid stroke? Bottom. So acceleration is always directed towards midpoint or fixed we discussed in definition of simple harmonic motion. Okay, everyone getting my point? Try to see the scenario here. Any doubt in this discussion, guys? So here, how is the direction of acceleration? How is the direction of acceleration, everyone? Downward? Okay. And what is the formula for acceleration, guys? What is the formula for acceleration? What is the formula for acceleration? Acceleration of piston at this point. Suppose we will assume this point as a point P. We will assume this point as a point P. So what will be the acceleration when it is at a distance from X point, from this point P? Suppose we assume this distance as a what? What we will assume this distance as a X. Okay, we assume this distance as a. So what will be the relation for acceleration? Omega square X. Okay, good. Omega square X. Very good. Now guys, why we need acceleration here? Why we are calculating acceleration? We have omega, we have a X. Okay. Sorry, we don't have a X here. We don't have a X. And why we need acceleration? Try to see the scenario. Why we need acceleration? So by Newton's second law of motion, everyone try to see the scenario here. By Newton's second law of motion. What is Newton's second law of motion, everyone? Force, summation of force is equal to what? Mass into the acceleration. So in this chapter, which sign conventions we follow? Which sign convention for force we follow? Forces in the direction of acceleration we consider as positive, opposite forces negative. So here 6G plus pressure force, pressure into area of piston, pressure force is equal to pressure into area of piston minus F, mass into acceleration. So F will be equal to what, everyone? F will be equal to what? 6G plus pressure into area of piston. Try to see the scenario here. Very simple discussion. Minus M into A. Okay. Now, if we need this value of F, what is unknown here, guys? We have a 6G, we have a pressure, we have an area of piston. Means how to calculate area of piston? We have a dia of piston. Try to see the scenario. What we have? We have a dia of piston. So piston is what? Cylindrical. So what will be the area of piston, guys? Pi by 4, dia of piston square. Okay. So what is unknown here? So if you need a, guys, if you need a, what is unknown here in this expression, guys? Acceleration is unknown. Acceleration is unknown to us. And for acceleration, what we need, guys? For acceleration, what we need? We need a X. And how to get a X, guys? Suppose if you want to find out acceleration, how to get a X? How to get a X? Guys, observe this drawing. How to get a X? R minus X. Okay, sorry. R minus 90 mm means point. X is equal to what? X is equal to what? R minus 0.09 meter. Okay. But how to get R? R is unknown here. Then how to get R, guys? Okay. R is equal to what? R is equal to what? Stroke by 2. R is equal to what? Amplitude of R means what? Amplitude of SHM. How to get R? Amplitude of SHM, stroke by 2. Then what is unknown here now? Stroke is unknown to us. Okay, everyone getting a point? So here in previous question, they have given us stroke, they have given us a directly, and from stroke we calculate amplitude, and from amplitude what is here? We got the value of X. Now what is the extra thing in this question they have given to us? Guys, that I have not written on the board. What is the extra thing they have given us on the question, guys, in the question? What is the extra thing they have given us in the question, everyone? What is the extra thing they have given us in the question that I have not mentioned here on the board? Or you can say, I forget to write that one. I forget to write that one. What is that thing they have given us here? See, read the question here, everyone. Everyone read the question here carefully. Okay. Which thing I missed, guys? Which thing I missed? A single cylinder, double acting vertical bilge pump. Okay. So this thing also I have not written. Then I have written N 50 revolution per minute against a discharge of 1.8 bar. I have that written also. The flow rate, guys, see the scenario here. What they have given us? Flow rate is what? 18 meter cube per hour. Okay. So if you studied hydrodynamic, guys, Those who studied hydrodynamic, they may know term flow rate, mass flow rate, volume flow rate. So here they have given us a volume flow rate. How we come to know that it is volume flow rate? Volume flow rate means in 1 second or in unit time how much volume is delivered. Okay, so here how much volume is delivered? 18 meter cube per hour. Guys, are you getting my point? Try to see the scenario here. So here flow rate is what? Volume flow rate is that how much? See these things I have not written here on the board. So in the question what they have given us, guys, in the question that which extra part they have given us, this is a generalized scenario. So volume flow rate. How much is the volume of volume flow rate, everyone? See, they mentioned only flow rate, but how do we come to know that it is volume flow rate, guys? Those who, okay, meter cube, from meter cube is unit of volume. So if they have given instead of kg or ton, then that will be what? Mass flow rate. Okay, so 18 meter cube per hour. Is it okay, guys? But per hour, guys, is not our favorite. Per hour is not our favorite. So we have to convert this volume flow rate. Everyone try to see the scenario. We have to convert this volume flow rate into what? Per second. So 18 meter cube per hour means what? 18 divided by, we need per second. So 18 divided by 3600 meter cube per second. Any doubt in this discussion? Per hour means what? 1 hour means 3600 second. Okay, anyone, any doubt in this discussion? So volume flow rate will be equal to what? Everyone please do the calculation and tell me the value of volume flow rate. 0. So 18 divided by 3600, 0.005 meter cube per second. Okay, so here, so if you guys, if you want to solve this question further, what we need? If you want to solve this question further, we need what? First of all, we need a stroke. From stroke, we will get a R. From R, we will get a value of x. And from x, we will get a acceleration. And in B part, guys, if you observe the B part, in B part they ask us power. Power means what? Force into velocity. So we need a velocity also. And for velocity, what we need, guys? Velocity is equal to what? Omega under root of r square minus x square. Okay, everyone getting my point? Try to see the scenario here. So at the end, we need a stroke. If we get the value of stroke, then and only then we can solve the question further. Try to see the scenario, very simple discussion. So before going further, guys, first of all, we will write down all these given things. Then from these given things, from this volume flow rate, we are going to find out what we are going to find out. We are going to find out stroke. And from stroke, we are going to find out R. From R, what we are going to find out? We are going to find out X. Okay, everyone getting my point? Try to see the scenario here. Okay, so everyone, please, first of all, don't write. Okay, first of all, guys, okay, first of all, write down this thing. Then this one, this drawing, then this mass. After that, this volume flow rate. This is the most important task of this question, guys. We can say a twist. We need a general knowledge here, a little bit a basic understanding of basic concepts. It is basically from hydrodynamic this part, but this is a generalized thing. Okay, if you are good with hydrodynamic part of heat, then this thing will be very easy for you guys. Okay, please everyone complete all this thing. So guys, now first of all, guys, what is meant by volume? Before going further, what is meant by volume? Then we will see how to do the calculation. Volume means what? Area into length. Volume means what, everyone? What will mean by volume? Volume means area into length. So here what will be the length? Here what will be the length? Stroke. Okay. Try to see the scenario here. Here see. Volume means what? Area into length. Okay. And then we will discuss what is meant by volume flow rate. Okay. Now guys, see, this is what a double acting pump. See, for double acting pump, try to see the scenario here. For a double acting pump, double acting means both the sides. On both the sides of piston there will be water. Okay. For a double acting pump, So what will be the scenario for double acting pump, everyone? What will be the scenario for double acting pump? What will be the scenario for double acting pump? See, double acting pump means what? In every stroke, okay, means in every stroke, okay, in there will be what? In every cycle. Instead of every stroke, we can say in every cycle. What is meant by one cycle? Starting from TDC, coming to BDC, and then going back to TDC. Okay, try to see the scenario. TDC to BDC, and again coming back to the TDC. That is meant by one cycle. TDC to BDC and BDC to TDC. So in every cycle, in double acting, every cycle, how much water will be removed, guys? How much water? Equal to swept volume. Try to see the scenario here. So how much water will be discharged in every cycle? See, in one stroke, Vs. But in one cycle, how many strokes here? TDC to BDC, one stroke, and BDC to TDC, another stroke, two strokes. So in one cycle, there will be two strokes. So in one revolution, how many strokes will be there? There will be two strokes. So in each, so here there will be two strokes, and in every stroke, guys, so going from TDC to BDC and going again BDC to TDC, so every stroke there will be removal of water. Every stroke there will be discharge of water, means because discharge on both sides of the piston because of the double acting pump. Try to see the scenario here. So in every cycle means in every one revolution. Here cycle is one revolution, guys. This is a pump. This is not a IC engine. So here in one revolutions, how much water is discharged, guys? Not only one complete swept volume, two times swept volume, guys. See, two times swept volume. Try to see the scenario here, because it is double acting. So here, whenever there is a one complete revolution of the crank, here piston going from, suppose TDC to BDC and again BDC to TDC, so that is meant by one complete revolution. So for one revolutions, how much water, guys, discharge? Equivalent to what? 2 times Vs. Okay, 2 times Vs. Why 2? Why here 2 with us? What is meant by double and what is meant by Vs, guys? Swept volume. These things you may study it in your HEAT chapter 1, means gas laws chapter. In that chapter there will be concepts of swept volume and all that things. You need that concepts. There are few questions are there. Okay, so 2 times swept. So that is for one revolutions. Now, guys, what is meant by volume flow rate? What is meant by volume? So in one revolution, this much amount of volume will be discharged. Okay, this much amount of volume will be discharged in one revolutions. But what is meant by basically volume flow rate? What is meant by volume flow rate? Volume flow rate means amount of volume discharged in unit time. Unit time is in 1 second. So guys, here how many revolutions with us here? There will be 50 revolutions per minute. So in 1 second, how many revolutions? N by 60. Guys, try to see the scenario here. So in one revolution, so there will be 50 revolutions in 1 minute. So there will be there is how much revolutions here, everyone? 50 revolutions per minute. So in 1 second, how much revolutions? 50 divided by 60. So here we calculate time for one revolutions, means here for one, this is for one revolutions. Everyone try to see this scenario. Volume per revolution. And here we are going to say N by 60. N by 60 means what? Number of revolutions per second. Everyone try to see the scenario here. Revolutions per second. So revolution will get cancelled, and at the end what we will get? Guys, if we cancel revolution, try to see the scenario. If we calculate revolution, see. So N by 60 means what, everyone? See, why I am explaining you all these things? Because you should not memorize all these things. These are the concepts. So revolutions per second. So revolution will get cancelled, and at the end volume per second. That is meant by our volume flow rate. Everyone getting my point? What is meant by volume flow rate? Try to understand the scenario. Okay, very simple discussion. Volume flow rate. Anyone have any doubt in this discussion, guys? Anyone have any doubt in this discussion? So in this way, whenever we have a double acting pump, that is 2 times Vs. For single acting pump, what will be the scenario, guys? For single acting pump, what will be the scenario? Here 2 will not be there. So in every revolutions, volumes discharge will be equal to what? Equal to only Vs. And why n by 60 why we multiplied? Because we want volume per second. That is meant by volume flow rate. Na? What is meant by volume flow rate? Volume discharge per second. Try to see the scenario here. Huh? Then, so volume flow rate will be equal to what? Volume flow rate will be equal to what? 0.005 2 times, okay, swept volume means what? Pi by 4 dia of piston square. How much dia of piston here, everyone? How much is the dia of piston? Dia of piston is how much they have given us? 0.12 square, and into stroke is equal to what? 50 by 60. Try to see the scenario. Very simple discussion. Any doubt in this discussion, guys? Any doubt in this relation? How we got this relation? Try to observe the scenario here. Especially this relation, guys. These are the only I have substituted the things. Now, any doubt in this swept volume? See, these things you may study it in your head. Swept volume means pi by 4 d square L. D means dia of bore or dia of piston. Okay. Any doubt in this swept volume equal to what? Why we got to here? Why we have multiplied it by n by 60? Try to observe this scenario. So here stroke will be equal to what? What is our final target? We have to find out what? What we have to find out? Stroke. Stroke will be equal to what? 0. Try to see the scenario. Very simple discussion. 0.005 multiplied by 4 multiplied by 60. Okay. 460. 2 times pi 0.12 square into 50. Okay. Everyone do the calculation. We are nearer to the hour. So if you got the stroke, then remaining question is very easy. Only the twist is what? How to get the stroke here. And why we need a stroke? From stroke we will get a value of R. From R we will get the value of X. Okay. Simple. See the scenario here. Huh? So everyone please do the calculation of the stroke. Everyone. (0.005) multiplied by 4 into 60 divided by what? 2 times pi 0.12 square into 50. Okay, how much stroke we are getting, everyone? How much stroke? 0.26526. Okay, unit meter. Okay, everyone getting my point? Try to see the scenario here. Then from stroke we can easily calculate R. Okay, everyone please write down these things. Okay, very simple discussion. Everyone please complete. Just now we calculated this stroke. Now from this stroke what we are going to calculate? So here I have written all these things for my reference here, volume flow rate and stroke. So from stroke what we are going to calculate? Amplitude of SHM. What will be the relation for amplitude of SHM, everyone? Amplitude of SHM. Amplitude of SHM means what? R. R is equal to what, everyone? Stroke by 2. How much is the value of stroke, everyone? How much is the value of stroke? Stroke is what? 0.26526. Check it, guys. Is it okay? Divided by 2. So here we will, in this way we will get the value of R. So please do the calculation. 0.26526 divided by 2. How much? 0.26526, 0.13263 meter. So we got the R. From R what we will get? From the value of R, guys, from the value of R what we will get? We are going to calculate X. Okay, and what will be X? R minus 90 mm means what? R minus 0.09. Okay, try to see the scenario here. So X will be equal to, what is the R? 0.13263 minus 0.09. So X will be equal to what? Everyone please do the calculation. So 0.13263 263 minus 0.09. How much everyone? 0.04263 meter. Okay. So we got the what we got everyone? What we got? We got the value of x. From x, guys, what we are going to calculate? We are going to calculate acceleration. Acceleration is equal to what? Omega square x. So omega is equal to how much? 5.236 square. X is how much everyone? 0.04263. So acceleration. So please everyone, 5.236 square multiplied by 0.04263. How much everyone? Acceleration 1.87 unit meter per second square. So we need acceleration in A part. In B part they are asked us power also. For power we need a velocity. Force into velocity means power. We studied these things, force into velocity and power, in our linear motion chapter. So try to see the scenario here. So power, sorry, not power, we need a velocity. What is the relation for velocity? Omega into what? Under root of what? Under root of x square. Okay, good. Under root of r square minus x square. So velocity omega is what? How much is the omega? 5.236. 5.236 under root of r square. R is what? 0.13263 square minus x is what? 0.04263 square. Okay, everyone getting my point? Try to see the scenario here. So please do the calculation for velocity everyone. Please do the calculation for velocity. 5.236 multiplied by under root of 0.13263 square minus 0.04263 square. Okay, how much value we are getting? 0.6576 unit meter per second. Okay, everyone getting my point? Okay, then we will go for the A part and B part, guys. Okay, everyone, these are the prior calculation we needed for. We need acceleration for the A part because we have to calculate force from Newton's second law of motion. So for that we need acceleration, and in B part we have to calculate power. Force into velocity means power. So for that we need a velocity. Okay, everyone getting my point? Try to see the scenario here. So before going for the A and B part, write down R, then this x calculation, then this acceleration calculation and velocity. So please everyone complete all these things. What they are asking us in the A part, guys, here? The force required to move the piston. What they are asking us here, A part, force required to move the piston. Try to see the scenario here. So what is our target? We have to find out force required to move the piston. See, here I am going to draw the diagram of the piston. Very simple scenario here, not that much difficult. So this is what our piston. We have seen such type of diagram. Okay. This is what a piston. Piston is, how much is the mass of the piston? Mass of the piston and that entrapped water is what? How much? 6 kg. So total weight will be what? How much will be the total weight? 6 times g, 6g. So this is what? Pressure. Okay, everyone getting my point? So pressure, then there will be what? A force F. Okay, that is due to the rod. So that is what F. This is what our target, this force we have to find out. And what will be the direction of acceleration here? The position of piston is what? What is the position of piston? So with this is what the position of piston. Point P is what? Position of piston. With respect to point P, what is the position of mid stroke? Mid stroke is downward, and we discuss, guys, acceleration is always directed. Mid stroke means fixed point, mid stroke or fixed point, same things. So acceleration is always directed towards what? acceleration is always directed towards what fixed point? Okay, so here what will be the direction of acceleration? Acceleration is what? Towards fixed point A. So here we calculated A just now. So by Newton's second law of motion, everyone try to see the scenario here. Very simple discussion, nothing much difficult here. So by Newton's second law of motion, by Newton's second law of what? Everyone, by Newton's second law of motion, by Newton's second law of motion, summation of force is equal to what? Summation of force is equal to what? Mass into acceleration. Okay, the forces in the direction of acceleration will be considered as positive and opposite forces negative. So here 6g positive, which will be the opposite force here? What will be the opposite force here? Sorry, minus F is opposite, and then pressure force, pressure into area of piston, pressure into area, pressure force minus F is equal to 6 into A, and we have to calculate what we have calculate? We have to calculate F. So F will be equal to what? 6g, pressure, area of piston is what? Pi by 4 into dia of piston square. Try to see the scenario here. Minus 6A, 6 into A. Any doubt in this discussion, guys? Try to see the scenario here. Very simple discussion. So F will be equal to what? So here F will be equal to what? 6, G is what? 9.81. Pressure is how much? 1.8 into 10 raised to the power 5. Pi by 4. Dia of piston is how much? 0.12 meter here. So 0.12 square minus 6 into what? Acceleration is how much here? Just now we calculated, guys, how much value of acceleration? We calculated 1 point, how much? 1.687, 1.1687. So please everyone do the calculation and tell me the value of force. Everyone do the calculation and tell me the value of force. Please, 6 into 9.81 plus 1.8 into 10 raised to the power 5 into 0.25 pi 0.12 square minus 6 into 1.1687. Okay, how much value we are getting, everyone? Two 87.6 unit Newton. Okay, everyone getting my point? Try to see the scenario here. So in this way we got what we got here. We got the value of F. What we got here, everyone? We got the value of F. Okay. Now what they are asking us in the B part here, input power to the motor. Everyone try to see the scenario here. What they are asking us here in the B part, input power to the motor. Try to see the point here, input power. So they are asking us input power to the motor, input power to the motor. Try to see the point here. Now what is meant by efficiency? They have given us the efficiency of motor, this 0.78, 78% efficiency of motor. What is meant by efficiency? Efficiency means what? What is meant by efficiency, everyone? What is meant by efficiency? What is meant by efficiency? Output. Okay, means output power by what? Input power. Okay, that is meant by efficiency. Try to see the scenario here. So what will be the input power? What will be the input power, everyone? Input power will be equal to what? Output power by what? Efficiency. So input power. So what will be the output power here? First of all, output means what? We are getting, okay, where where will be the output from the motor? Okay, to the that shaft, okay, to the rod. So that rod force and that velocity will be what? Output from the motor and divided by efficiency. So what will be the force here? How much value of force we just now calculated, guys? 20. Can you tell me exact value, guys? Anyone? 20.6 divided by what? Sorry, multiplied by what? How much velocity we calculated before? 6576. So this much velocity we calculated, guys, divided by what? Efficiency 0.78. Okay, anyone have any doubt in this discussion? So try to see the scenario here. So input power will be equal to what? Everyone try to see the scenario here. Huh? So input power will be equal to what? 2087.6 multiplied by 0.6576 divided by what? 0.78. Okay, 2087.6 0.6576 divided by 0.78 1760. Okay, watt. Okay, power. What is in not in means power is not in Newton, huh? Power must be in watt. Okay, so this is what our answer of B part. Anyone have any doubt in this discussion, guys? Very simple discussion. Okay, the only twist in this question is what? That volume flow rate. From volume flow rate we got the stroke, from stroke we got the R, from R we got the X, from X we calculated the acceleration and velocity, from acceleration we got the force, and from force and velocity we calculated the input power. Any doubt in this discussion, guys? So please complete this B part of this question, please everyone. We are going to see some theory related to this question. Just now we have seen a volume flow rate and all that things. Okay, so we are going to see one theory before that. So here we are going to see theory, just the questions that we just now covered with related to that questions. We are going to cover some theory. Guys, give the note. Everyone give the note. In note, give the first point, mass flow rate. Mass flow rate will be equal to what, guys? Mass flow rate is equal to what? Density into volume flow rate. Okay, what will be the mass flow rate, everyone? Mass flow rate will be equal to what? Mass flow rate is equal to what? Density into what? Volume flow rate. Okay, that is what our first point. Second point, try to see the second point. Second point, we are going to see, just now we have seen some relation. For just now we have seen few relations. First we have seen for single acting. Okay, for single acting pump, volume flow rate will be equal to what, everyone? For single acting pump, volume flow rate, everyone try to see the scenario here. Volume flow rate. Okay, volume flow rate will be equal to what, everyone? Volume flow rate will be equal to what? For single acting, swept volume into N/60. Okay, and what is meant by swept volume, everyone? What is meant by swept volume? Pi/4 into, okay, I will write down here. So volume flow rate, everyone try to see the scenario here. Pi/4 into d square into stroke into N/60. And what will be the unit of volume flow rate here? Unit of volume flow rate will be what, everyone? In meter cube per second. Meter cube per second. Okay, so here, so whenever we have a single acting pump, for single acting pump, so we will consider this is what our note 1, this is what a note 2. So for single acting pump, note 2. Then we have seen volume flow rate. From volume flow rate, we have seen mass flow rate is equal to density into volume flow rate. So here, so mass flow rate will be what? What will be the mass flow rate for single acting pump? Mass flow rate will be equal to what? It is denoted by m dot. M dot will be equal to what? Density is denoted by what? Rho. Volume flow rate, density into volume flow rate. Volume flow rate means what? Vs into n by 60. So Vs into n by 60. Okay, everyone getting my point? Or m dot is equal to what? And swept volume means what? Pi by 4 d square into stroke into n by 60. And what will be the unit of mass flow rate? What will be the unit of mass flow rate, guys? What will be the unit of mass flow rate? In kg per second. Everyone try to see the scenario here. Mass flow rate is in what? Mass flow rate will be in what? Everyone, in kg per second. Okay guys, are you getting my point? Try to see the scenario. So this is discussion for single acting pump. Volume flow rate, mass flow rate. Okay, and how to see, generally in the question they will not give you volume flow rate or mass flow rate. They will not mention this. They will just say flow rate. And how we come to know that it is mass flow rate or volume flow rate? See the unit. If it is unit of volume, then volume unit means what? Meter, liter, meter cube, liter. All these things are unit of what, guys? Volume. Ton, kilogram, gram. These are the unit of what? Mass. So from these units, you will come to know that it is a mass flow rate or volume flow rate. But for volume flow rate, we will use meter cube per second, SI unit, standard unit, and mass flow rate, kg per second. So this discussion for single acting. Then similarly, third point, third note, for double acting pump. Everyone try to see the scenario. Third note will be for what? For double acting. For double acting pump. So for double acting pump, so first of all we will say what? What we will say, everyone? Volume flow rate. Volume flow rate will be equal to what? 2 times into Vs. 2 times into Vs into what? N by 60, or another relation. 2 times Vs means what? Pi by 4 d square into n by 60. And what will be the unit, everyone? What will be the unit for volume flow rate? Unit for volume flow, meter cube per second. Okay. What I have missed here? Important point I missed. Guys, swept volume means what? Pi by 4 d square into stroke. See the scenario. Stroke into n by 60. Very simple discussion, guys. And this volume must be in what? In meter cube per second. Okay guys, are you getting my point? And then mass flow rate will be what? Mass flow rate is equal to what? M dot is equal to what? Density into what? Volume flow rate. And how much volume flow rate? 2 times Vs into what? N by 60. So density 2 times Vs is what? Pi by 4 d square into stroke. See the point, very simple discussion. We may need these things, guys. So in this way we will get mass flow rate and volume flow rate. Very simple discussion. Okay, this is some extra part related to this numerical, guys. So in this question they have given us a volume flow rate, but in future there may be a chance, guys, in future instead of volume flow rate they may give mass flow rate also. So you should be good with. And how we get mass flow rate? Density into volume flow rate. Okay, mass is equal to what? Density into volume. So mass flow rate is equal to what? Density into volume flow rate. Okay, everyone getting my point? Try to see the scenario here. So guys, write down this first: mass flow rate generalized relation, then for single acting pump, and then double acting pump. Please everyone write down this point.